Okay, so let's get started. Thank you for being the brave ones left on the last session on TechDays. I hope you enjoyed yourself and had a good TechDays conference and learned a lot of things and gotten a lot of inspiration. My name is Robert Folkesson. I've been the host for the architecture track here at TechDays. So hopefully you've been to a couple of the sessions at the architecture track. I know Daryl has been because he gave one of the talks today. Excellent one. Thank you for that. We're going to round off this Tech Day with a discussion around how AI will affect us. Both kind of in the broader sense, how it will affect us as humans, but of course, how will it affect how we think about the systems we're building in the future. And I'm going to sit down with my great panel here, and I'll let you introduce yourself. So, Rebecca?
Thank you. So hi, my name is Rebecca Sedering-Angström. I'm a director at Ericsson Network Society Lab. I have a background in about 10 years looking into consumer insights when it comes to emerging tech. So I've been talking to a lot of people about artificial intelligence, virtual reality, augmented reality, and things like that. Yeah.
Excellent. And Jennifer, you're famous from the keynote and from before.
I don't know about that. My name is Jennifer Marsman. I work for Microsoft as a principal software development engineer. And I've been with Microsoft for about 15 years. And my graduate work was in machine learning. And I'm very fortunate to continue to get to do machine learning projects, coding with customers, as well as some of my own fun side projects as well at Microsoft.
My name is Robert Luciani, and I am the CTO of a company called Laketide. We do big data and machine learning, so during the days we code CUDA kernels to get our code to run faster, and at night we play Quake with each other. My background is I worked at Microsoft for a number of years. I studied at Chalmers University, computer science, and I also had a brief stint in telecom, where I got a feel for big data sets.
Excellent. So thank you all for being here and taking the time. Appreciate it. So no panel touching the subject of AI and machine learning is complete without asking the question, what is AI? Because at least me, myself, I feel like machine learning is kind of a fairly, it's not a simple subject when you dig into it, but the concepts are fairly easy to like grasp. So you get a linear regression is in its simplest form. It's like putting a ruler on some data points and predict some new data point. But AI is such a fuzzy word. So what is it? How do we define it?
Do you want to take it first?
Well, I think that ML is worth distinguishing from statistics, first of all, where statistics is about making a hypothesis and then believing that your data is stochastic and then checking if that hypothesis is true. And ML is a completely different field that was born out of computer science, not out of social studies. And it treats the data and the model as unknown, and it algorithmically develops a hypothesis. So things that ML people care about are, does the model converge? Can it learn things efficiently? And many other things that statistics don't really focus on. And AI is just an extension of that. But one thing that's interesting now is, you know, if we talk about e-tailers still a little bit, but really internet is embedded in our society in such a way that you don't necessarily have to have an e-phone or an e-this. It's just the internet's a part of it. And the same thing with AI. We're talking about it now because it's pretty novel, but I don't think there's going to be a need to really define it quite so rigorously. It's like if monkeys break a nut with a rock, we don't call that augmented strength. It's just, you know, strength or a tool or something. It's going to be the same thing with AI. It's intelligent, but it doesn't need to be something particular.
Okay. Do you agree?
Yeah, I'm in the same line at least. What we are seeing in the study and the research that we are doing is that already today, a lot of consumers are looking for the possibility to interact with their everyday devices around them using AI rather than using a screen, because it's also more convenient for them to have that kind of interaction. And from a consumer point of view, I would say that artificial intelligence is where you can have an intellectual exchange with a computer or device. So from my point of view, I wouldn't narrow it down to a specific technology. It's more of having that intellectual intelligence feedback to you.
And it's funny how much the definition has changed over time as well. I know when I was doing machine learning work like in school 15 years ago, back in ancient times, what we considered artificial intelligence then was very different. It was the idea of being able to have a machine be able to do the same things that a 2-year-old can do with ease, things like recognizing faces and understanding emotion and things like that, which were impossible for machines at that time, and very, young children could do them very well. And so that was like artificial intelligence. And fast forward 15 years to today, and those are essentially solved problems in machine learning. Like, we can do that very easily. And so I think the definition of what is artificial intelligence has then evolved. Some people define it as kind of a general purpose intelligence, so someone that can kind of form its own goals and operate like a human would. And some people use it just to refer to things like bots. So it is definitely an overloaded term in the industry.
Yeah. So I found it interesting that you mentioned the UI part of it. Yeah. So for those of you who went to the keynote this morning, James Whittaker, he spoke about the invisible user interface. It's like these intelligent services that kind of figure out your intent. Yeah. So I guess that will be something that we who are building system will have to start thinking about.
Yeah, for sure. I do believe so. If you look at the consumer interest in this. So already today, as I mentioned, people are looking for this kind of interaction. But it's also not only for the convenience of not needing to pick up a phone or a screen, it's also because it can save you time. And one of the examples, I don't know, any of you commute to work by train? It's only me? No, a few hands here. So then you probably know at the end of every month, you start realizing, oh my God, my train ticket is out. I need to get a new train ticket. And I have to stand in queue. And if you're anything like me, you come to the train station pretty much just like 5 minutes before the train leaves. And then there's a queue you have to stand in. And you go like, oh my God, and then you probably miss the train if you're anything like me. But the thing is here, why can't my phone just learn this? Why can't it understand, okay, Rebecca, you're going on the train again, like you do every month. So probably what should happen, I believe, is that I just step on a train, and the phone and the train recognizes me and my behavior, and it automatically gives me another train ticket. Because then it's convenience for me, and it saves me time, it's adding some kind of value to me. And so it's not only about interacting by voice and asking a device, but it's also having that kind of interaction that goes seamlessly into your everyday life.
Yeah. And so the canonical example of AI is the autonomous car. I don't have a Tesla, unfortunately. I have a Ford. But it does have like this driver alert system. So it kind of figures out if I'm starting to drive a bit too wobbly, and I've been doing it I've been driving too long, and it figures out I probably need a rest. So so I get this warning that, hey, grab a cup of coffee and stop the car for a couple of minutes. And these kind of like intelligent services that help you with your everyday life, is that AI? And as you said, we'll stop talking about AI. It will just be there, yeah. I guess.
Yeah. I think things like that are wonderful in terms of helping people transition. So when you think about the issue of autonomous vehicles, the very first time you set foot in a car and it does not have a steering wheel and it does not have a brake and you are completely at the control of the developer, like that's scary, right? And so I think what services like that are really good for is helping you transition, right? So right now, like they've gradually added like the parallel parking feature that will take care of parallel parking for you. So you're like, oh, that's fine. I don't mind giving up control of that because I hate parallel parking and I'm really bad at it. So go ahead, parallel park for me, and it'll do that. And then, oh, and there's lane assistance. Oh, okay, so we can do that. And there's cruise control. And oh, okay, well, that works. And so it's almost like it gradually helps you make that transition. So I think services like that are imperative because it's going to help us as a culture of humans be able to make that transition. And it's the same thing with things like online banking. Like, do you remember how terrifying online banking was when it first came out? Everyone was just like, oh my gosh, I'm a developer. Like, I could hack this. I know how to do, you know, and it was very scary for a lot of people when online banking first happened, but then they kind of had various services in different levels, and they kind of helped you, dip your toe in the water and gradually move over, and now people just, take a picture of their checks to deposit them and everything is fine. So I think there's it's a nice progression.
Yep.
Mm-hmm.
If only people knew that airplanes land themselves already, and they're harder to land than to drive cars.
Yep.
Yeah.
But what counts as AI? There's a funny anecdote about the philosopher Dreyfus, who was adamantly against AI and that kind of stuff in the early 90s. And this one researcher got so mad that he coded up a really crappy chess-playing algorithm that a 7-year-old that was trained could reasonably beat. And he said, Dreyfus, because back then it was considered uniquely human to be able to play chess because it required strategy, it required thinking, and a number of other things. And of course, this algorithm beat Dreyfus, who was an amateur, which meant, well, does that mean that he's not intelligent? No. Does that mean that he's less clever than a 7-year-old? No. And a number of other things. So all these assumptions, perhaps we need to rethink them, but also I think what AI is going to show is that we're not quite as clever as we think we are. And one of the things one of the first experiments I did when I started at university was they had this vacuum cleaner that would shoot air and it would balance a ping pong ball. And I saw actually a better example of this today. There was a cart that would take 3 sticks and balance them on each other and then just keep them balanced. And at the university, it would let me try to balance the ping pong ball with a vacuum cleaner, and as soon as you try to do it yourself, it would just shoot away. And I was like, okay, I'm never going to beat this machine, ever. And why would you want to? And it doesn't really matter if it's intelligent or not. It's better than you are. So we need to stop comparing ourselves or having ourselves as the bar for intelligence. Because, like you said, a lot of people can't even parallel park. So obviously, in that sense, cars are more intelligent than we are.
I would like to add to that. So we did a piece of research on this one with autonomous cars. But rather than asking people who are driving cars, because they are going to be extinct, we asked the pedestrians, people who are moving around the car. And already today, we saw that 1/4 of these advanced internet users would feel more safe if all cars were automated. And I think that is saying a lot, quite a lot, that we don't really trust all other drivers to be good drivers. We have heard about people that, being drunk and driving. We will probably never hear about an autonomous car being drunk and driving.
Or checking Twitter.
Or checking
or being
Twitter.
distracted.
Yeah.
But you do have that classic ethic problem where the car has to decide where to go and has to decide on either collide and potentially hurting the driver or run someone over, for example. That's like the classical example of a moral problem.
You're not asking me to answer that one, right?
No,
Yeah.
I'm not asking you to answer that, but it's
Yeah.
possible that we will let the machine take life and death decisions then.
It's a huge ethical question that people ask a lot. The thing to remember, though, is that most of the time such accidents happen because as humans we get distracted, right? We are thinking, and I'm not even talking about like being drunk or checking your cell phone or the really bad things, but even just, I'm thinking about my day, I'm daydreaming, or I'm thinking about the 25 things I need to do when I get home, or, oh, did my kid, remember to finish their homework assignment or whatever, but you always have all of these things, processing in the back of your mind. And so you get distracted. You get distracted by the kid in the back seat. You get distracted by all these other things. The machine is never going to get distracted. So with that, I mean, the worst that could happen is the cycles are too full, and we can manage that with hardware and such. And so I think the majority of the time, these situations are just not going to occur with a autonomous vehicle, because it's going to anticipate that way further in advance than we will, just because we're more easily distracted.
Yeah, cars aren't going to drive 70 on a 50 road. Cars aren't going to tailgate other cars and stuff. But even if we were to posit that these scenarios do occur, like a deer jumps out on the road, well, the car would just run it over, so that's that. But let's just say a kid runs out on the road chasing a ball or something like that. Should it run over the kid, or should it crash the car and sacrifice the elderly driver in it? The thing is, if we have this scenario with all these autonomous cars, you have another choice that you're making at the same time, which is, if you decide we can't allow cars to make those ethical decisions, and therefore we will only allow humans to drive, you're necessarily sacrificing all those people that you could have saved. So you're already making a decision by not allowing these cars to make those ethical decisions. And then you could optimize that afterwards. But by not allowing these cars to drive now, even in their bad state, where they make mistakes sometimes, let's say 400 people die a year, and you could save 300 of them. Is it worth sacrificing those 300 people actively in the name of justice? I wouldn't say so. That's making an active choice of sacrificing those 300 people.
Excellent point, actually, yeah.
You brought up something that made me think too, which was really funny when you were talking about another driver. I actually was thinking the other day about how autonomous vehicles will affect road rage. Do you guys have a lot of road rage in Sweden? Because, we get it bad in Detroit. I know. and so people get like really, another driver, you were it's a long line of cars and another driver sneaks in front of you and people are banging on the horn and stuff like that. And I wonder how that will affect us. Because I know in the morning, like sometimes you're driving into work and there's just a person who's just not nice and does something mean on the road. And it can just like start your whole day off in a really bad note, And so I'm wondering, like, how will that affect us as a culture? Would road rage go away? Or instead of turning our anger towards another human, would we turn it towards the algorithm instead? Like, that autonomous, because maybe there's some kind of, bubble sort type algorithm where they're letting people in like this or that sort of thing. So I'm curious how that would affect road rage, honestly, autonomous vehicles.
Yeah. Thinking about autonomous cars, I came to think about you actually need to have the machine learning logic contained in the car, because like making a split-second decision, you can't call a server somewhere and wait for that machine learning solution to answer. So, and this was also something Jason Sander mentioned in his keynote, talking about the edge devices, like putting the logic, downloading the logic into the devices and making the devices themselves smart. So I guess that is something we have to, as developers and architects, start thinking about how we should handle, because devices, I guess, is an area that you, Rebecca, have been looking at a bit in your work as well, which will just explode, I guess, in the coming years.
Yeah. There's a privacy scenario that might be interesting for you. I saw an article that said Fitbit, with the help of your sleep data, can quite reliably tell if you're likely to have a miscarriage or not. That's pretty private information, and it's information that's not processed on the watch or on the smart device per se, but that is a capability of this edge device. And that these edge devices are very close to us and very personal to us. They know if you have smart lights in your house, they know when the lights in your house are on and that kind of stuff. So I don't know if there's a lot of development aspects to it, but it does raise a lot more privacy aspects, given that devices are smart clothes, that kind of stuff. Yeah. And your car as well. It knows where you are. It knows if you smoke in the car, maybe. It knows, Well,
the future of privacy is very interesting and something that I think that we have to discuss in length, and probably we need to do some kind of definition of what privacy really is in the future, because we are going to generate so much data. And from a consumer point of view, that data can also be used in a very convenient or good way for the user. But just jumping back a little bit before we jump into privacy with the IoT and connected devices, I understand the point of having the logic on the device, but at the same time, the way we are watching TV right now, a lot of us you are watching Netflix or HBO, and we do that on multiple of screens and in multiple of different settings and places. So I might start watching a film in the morning using my iPad in my breakfast table, and I continue watching it on the train or on the bus using my mobile phone, and in the end, in the evening, I watch the end of the movie on my big screen at home. And that is because I have, the possibility to have all the information in the cloud. And I think that when I start generating different information in my devices, being able to access that and let that knowledge or learning that it can come from one device also multiple into other devices, personal devices of mine, will be probably a benefit to the consumer as well. So we need to understand, how are they going to be used and what is the benefit of the consumer. Yeah. But just getting a connection is not really going to give us anything at all. My favorite example, can I just, because we have this, IoT is going to solve everything, and as soon as everything gets connected, it's like wonderful. My dad's first coffee maker, he loves Jura. You know Jura coffee maker? Yeah. So he loves them. He has had multiples of them. And his first one was actually one that could connect to the internet. It was like pre-internet. You could find it online with using a @ sign and everything. It's a very long time ago. So he could go online and turn it on. But the point of having it connected was really silly, because he still needed to go to the kitchen with a coffee cup and get the coffee. So the point of turning it on online, it was just a fluke, or it's just a crazy idea. And a lot of IoT today is that kind of thing. We just want it to be connected. But as soon as that coffee maker can be beneficial to me, so maybe it can learn from my iWatch how I slept, and it could know, in what mood I am in the morning. And so on Monday morning, when I step into the kitchen, it goes like, Rebecca, you are tired. Do you want extra strong coffee today? Yeah. I want a yes. Yeah. Then you have the benefit of having it connected, but then it also needs to learn from my other devices.
Right. I think the other thing to remember about machine learning is that there's really two phases to it, right? There's the training phase where you're gathering the data and actually building a model, and then there's actually using the model that you've built. And so when we talk about like edge scenarios and things like that, I see two different scenarios. So sometimes, like in the case of autonomous vehicles that you asked at the beginning, if you want to build a good model, you're going to want to aggregate data from lots of different cars and that sort of thing. So in that case, I think it makes a lot of sense to be sending all of that data to a cloud, to a common source, and train a model in the cloud. And then, as you say, you must have the model when you're using it on the device because of latency concerns, or if your internet goes out, or just speed and all those other things. You absolutely need it to be on the device. So you could train a model in the cloud and then push it to the device and then actually use it, call it in real time on the car. And then there are some other examples where you may want to do the whole thing, like the training as well as the using in vehicle. But I think that's definitely where the machine learning industry is going. And industry-wide, we're seeing announcements. Microsoft is doing work in this space. Google is doing work in this space. A lot of people are doing work making sure that this works well on devices as well.
There's one encouraging aspect with regards to IoT and deploying AI to it, and that is because AI, or deep learning in specific, are universal function approximators, you can do pretty complicated stuff that under normal circumstances would take a lot of computational power. The archetype example is one of the most complicated equations to solve of every equation is the Navier-Stokes equation, where you calculate the fluid dynamics of how fluids or air or anything goes around like a race car. But you can approximate those using deep learning, for example, and that's what people are doing also with experiments in the quantum world. They're trying to do approximations of it because it's cheaper. And similarly, you could probably deploy deep learning models onto very weak devices that could do things that under normal circumstances would require a lot of computing power if you're willing to accept an approximate solution. So maybe something that, I don't know, analyzes the environment or understands your speech or whatever, which with normal parametric methods would be very, very complicated. So in that regard, it might accelerate faster than the revolution of wearables has done up to now, because it's not quite as compute intensive as the stuff we've done in the past. You know, Palm Pilot and that stuff, that was never a big hit. This stuff is going to go faster, I think.
Yeah, cool. But coming back to the amount of data, so okay, we have the data from all the connected devices in the cloud, and with that data we have a large amount of personal information, and with that comes the integrity questions that can be quite hard. And GDPR, for example, the European law that is coming into effect next year in May, will have a big impact on that. I personally think that's a good thing. I'm not sure what you think.
Good, somebody's playing the devil's advocate here.
Because it will restrict what companies can do without giving permission from the user. But it will, of course, be hard. You will not any longer be able to just gather all this personal data and keep it forever, for example. And I guess one of the really kind of key things when having training data is to actually have large data sets. So I guess this will be a hard thing to work with.
It's definitely a big thing. So Microsoft has released publicly that they're fully committed to supporting GDPR. And we're working on doing all of that and getting everything ready in Azure by the deadline. And so it is something that we do. I would like to say that I think hopefully a lot of companies are following those types of practices anyway, or doing some of that. Or there wouldn't be, hopefully too many things. I know when we do collect data, we have very stringent privacy policies around everything that we collect, and no personally identifiable information. Or if you do have anything with PII, like if you ask to be contacted by Microsoft and give names and email addresses and such, that has to be stored in a completely different way than non-personally identifiable information. So we have a lot of stuff in place already, and then this is just taking, I think, the final step of making sure that you understand where to access it, you know how to delete it, like kind of that extra step. But I think we're on a good path to get there, and it is. I mean, the privacy thing, brings up a lot of very interesting information about like who owns the data, and when data things. Because I know one of the things that's very interesting is if I take a picture of myself and tweet it or something, then I kind of have the understanding that this is public domain and other people might use that or something like that, because I'm proactively putting it out there. But if I'm walking through a public place and there's a video camera on me and I'm not necessarily aware of it, or like dressing rooms where they're monitoring you but they don't tell you, or things like that, those are harder situations, because who owns that data and what are the expectations in those kind of scenarios? Because I think for me anyway, there's a privacy versus value like trade-off. Like I have an Alexa, an Amazon Echo in my home, and I'm okay with that. I'm okay with Amazon understanding my preferences and stuff, because we get value out of the Alexa. Like I enjoy it. We think it's fun, and Amazon gives me good recommendations because they know what I like. They can recommend good gifts to buy my kids at their birthdays and stuff like that. But I kind of understand that trade-off of, okay, I'm letting you see all this history, and in exchange I'm getting value out of it. But I think it's in the scenarios where maybe you're being recorded without your knowledge and stuff like that, where you're not proactively understanding the privacy versus value trade-off, and that's where it's an issue.
And I can only concur to this. In the research we have done, we see that there are 3 things that needs to be in place for consumers to willingly share their information. And that is transparency, to understand that your data is being used. It's permissibility, just to have that agreement. that is to be asked, basically. And then the third part is the value sharing, that I need to understand, I need to feel that if you're getting something out of using my data, I should get something out of it too. You know, it's my data, and if that is better recommendations, or if it's a lower price, or what it could be, but I need to feel that I get something out of it. But then again, if you're talking to consumers, it's really easy to understand data that I willingly put up there, like the photo, or if I share my email address and things like that. And it's a little trickier to understand, but still people do. You know, usage data. What movies do I watch on Netflix, and how is that actually building up the recommendation system then for Netflix, for instance? But then understanding aggregated data, or data that is being used, like at what time am I watching, or what browser am I using, and things like that. That is really hard to understand all these little details that are being collected about you. And then it's very hard as well to say, well, I'm okay with you using it, because I don't understand what you're collecting and what you're using it for. So we need to be, well, educating our kids or our employees or what have you to better understand what data or footprints I'm actually leaving out there.
I feel the complete opposite. I feel GDPR is a big disservice to consumers and is invented by people in Brussels for popularity contests. It's going to make consumers less aware of what actually happens to the data, because it's going to regulate things in such a way that consumers feel that they're safe when they might not in fact be. The nitty-gritty details of the GDPR are in fact the worst part, where an event like this would require a data processor agreements to just keep track of who is vegetarian or not, because that's personally identifiable information. They would have to have audits. They would have to be prepared to purge that data if a person requests it. Another thing is, you're going to have to ask for permission for every specific use of every data point. So if I were to collect data on your eating preferences, I might use it both to book dinners and to do something else. Who knows what. The point is that I can't use it for both of those cases. I can't use it to print a coupon book and book the dinner, because that would require two separate consents from you. So if Netflix collects your browser data to optimize what algorithm it uses, it can't use that personally identifiable information for another thing, which is to see where should we focus our development efforts and make a plugin for something, because that's a separate use case that would require a separate consent. There are lots of small, these are just basic things. There's so many small details that will ruin for small businesses that we haven't even scraped the surface yet. And what's going to happen is people are not prepared for it. Microsoft and these companies are super techy and ready to rock when it comes to these types of IT regulations. But banks, the silverbacks of the banks, they're not ready for this stuff. And neither are the small companies to be able to be 100% compliant. So I think it's going to be a big issue, and it's going to affect the consumers the worst.
It's definitely going to be a big issue, and I'm here you're kind of speaking from experience on the small business side. So I guess this has affected maybe the way you work with collecting data, I guess.
It might make our product not work at all.
Okay, yeah.
So
yeah,
in Europe at least, fortunately, there are other countries. But yeah, and I can't say exactly what our product is, but it's a product that would make city planning, for example, much better. So it could aggregate personally identifiable information and help with city planning and that kind of thing. If people don't give consent, naturally, of course, we can't use that data. And so, yeah, it could practically kill that use case.
Yeah.
I was thinking about a use case for machine learning for actually figuring out what unstructured data actually contains personally identifiable information, because that is usually a quite big problem, that you have this text field where you can fill in everything. So like a user can fill in, oh, he's religious, or he's this and that, and it's saved and it's personally, it's not only personally identifiable information, but it's also sensitive information.
There are really nice examples of this.
Yeah.
We know that AIs can identify you from your grammar. Given a couple of posts on Reddit, they can figure out who you are based on your grammar. That's personally identifiable information. There are companies that are doing geolocation, figuring out where people are, and they're like, well, we've taken away everything. We just have a point. That's nothing, right? Well, I only need 2 points, where you sleep and where you work, and I know who you are. 2 points. You can't anonymize that. There is no anonymization of that. And so there are lots of really edge cases. It's really difficult to explore all of those.
I don't know if this was a big scenario over here, but there was a, did you guys hear about the girl who found out she was pregnant from Target?
Yeah.
Did you? Okay, so that was big over here as well. But there was a story of, you know, this young girl, and the dad came to Target and was really mad. Why are you sending these ads for my daughter, like for pregnancy? And it was like a congratulations on your baby, like welcome packet of coupons and stuff for baby formula and such. She's like, she is like 14 years old. She is not, you know, why are you sending this stuff? And Target apologized. It's like, our algorithm must have gotten it wrong. We're really sorry. There's, you know, certain patterns of shopping, I guess, that women do when they tend to become pregnant. And then the father went home and then did find out that his daughter was in fact pregnant, and that Target had actually realized it before the father had. So there's a lot of things that you can derive from not very much data. To add on to
More than
your
you might
point.
imagine.
Yes, yes.
Another kind of aspect of giving out personal data on social media, for example, is that the algorithms learn who you are, basically, and will try to serve you the best possible information, because that's their job. Which leads to me getting a lot of information that I like, but also me thinking that modular synths is something that everybody else is doing in their spare time, which apparently isn't true. But it's like you get this kind of filter bubble around yourself when the algorithms picks what you should be interested of.
Yeah.
So it is. How will that affect us, and can we do anything about it?
Yeah, so what we're talking about, I think there are 2 sides to it. There is a technical part, and then there is a human part. So we're talking about filter bubbles, where algorithms are helping us identify or get information or seeing views from people in our social flows that we want to read from or see of. My filter bubble is a lot about AI, for instance. And you get shocked when you start talking to normal people and you realize that not everyone is into AI. But the other part is the human part, because I like getting that information. And I like having people in my social flow who like that same information. That's the echo chamber. And when I write something online, I like to hear from other people who are like-minded. So, and I believe that the technology part, or the algorithms, that is something that we can solve. We can help people get snippets or information or add to their interest area. Okay, so you like this, but you should also look into this because this can broaden your view. But it's a lot harder to make people go out and, you know what, you should be friends with this person. He or she does not like the same thing you do, but it would broaden your view. That is a lot harder to alter the human behavior in this way. And we have seen in our studies that we are actually, in fact, a lot better at getting further away from people who are not like-minded or who are different from ourselves. So we see that in a study we did with also advanced internet users in 14 major cities, we saw that about 1/4 say that they, on a weekly basis, turn down friendships requests or defriend people just because they have a different opinion than themselves. So I think that is what we need to work on a little bit. How can we make people really utilize the social networks to get to know different perspectives or different views? That is the challenge.
I think this is a place where AI can make a difference and can improve things quite a lot, because a lot of the naive methods we've used up to now are this person has also bought it, so you probably want to buy it. And in music, it's very apparent. This person listens to this music, so you probably also want to listen to it. But what happens when a new album comes out that nobody's listened to? I guess nobody wants to listen to it then. Or, and that's actually called the Daft Punk problem, because anybody that listens to Daft Punk only wants to listen to Daft Punk always and nothing else. But say you use deep learning. My friend Sander, who now works at DeepMind, wrote a recommendation engine based on deep learning for Spotify that analyzed the contents of the waveform to build high-level features of the music itself. So has electronic rhythms, has these types of harmonies, has these types of, and so on, and based on the content of the music itself, would be able to recommend other stuff. And it was very difficult because the KNN recommender engine would have a really good score, partially because what people listen to are what the KNN recommended in the first place, so that's a bias, but also because what it would recommend is stuff that people hadn't really listened to. So if you listen to, I don't know, lots of stuff out of my own personal taste sphere, but let's say you listen to the old school hip hop, like Jurassic 5. The deep learning algorithm would be able to know that Africa Bambaataa or Grandmaster Flash was similar, even though nobody necessarily listened to those two other people because they had the same types of rhythms and that kind of thing in it. And I think it's the same thing with Facebook and other places where potentially deep learning could recommend things in a more subtle way. Rather than, this guy got lots of likes, you probably want to be friends with them. Maybe, people maybe get rid of people on their Facebook feed because they're confrontative. But what if deep learning could recommend this article that isn't so confrontative, but maybe is a little bit different, and you might be interested in it? You probably are interested. You're just not looking for a fight and that kind of stuff. I think there's lots of room for AI to make things better rather than worse when it comes to this bubble thing.
Have you seen any example of when bias has been a problem in like more enterprise-like setups?
I could go on for the rest of the panel on bias, like so many things. There was one example of a city. I was doing some city planning, and so they wrote an app where people could identify potholes and where potholes were found in the city. And so, of course, they rolled out the app, and people started reporting potholes. And they found that all of the potholes were located in the middle to upper-class neighborhoods. And, duh, because the people that had smartphones were in upper to middle-class neighborhoods. The lower-class people didn't necessarily have the smartphones, which was the mechanism for reporting the data to actually get that. So there was inherent bias in the data that you were making a huge assumption that people had a cell phone that could, like an iOS or Android cell phone, a certain kind of cell phone as well. And so, if you don't have a web presence, then there's a huge assumption right there. There's also been a number of other examples. There's, you can see there's interesting stuff around gender bias as well that we've seen. If you translate, and even today, if you use translation things and type in something like she is a doctor, he is a receptionist into Google Translate and translate it into a language neutral where there's neutral pronouns like Turkish, for example, and then translate it back. So translate it into Turkish and then translate it back, it'll come back as he is a doctor, she is a receptionist, because it associates the she pronoun with receptionist and he with doctor. So there's a lot, there's just so many different examples, and you see them with two other examples that at Microsoft. There was one example where some folks were doing predictive policing in Chicago, and that's one example that scares me like crazy, along with insurance and some of these other things, because any bias that was inherent in that police data, if they're trying to predict people that were likely to go to jail or criminals or such, and you're using historical data, your model is only as good as the data that's going in. So garbage in, garbage out. So if historically a certain ethnic group was targeted or arrested more frequently, then the model is going to continue to assume that these people should be arrested because it is only learning from that data. So any bias in that data is going to perpetuate in the model. And then one other example, Microsoft actually was part of this, and this was one of the ones that made me a little squeamish, is there was a school district in Tacoma, which is a little bit south of Seattle, and they were doing, trying to predict which students were most likely to not graduate or to have struggles in school so that they could, and they did it for the right reasons. I mean, their hearts were in the right place. They wanted to be able to proactively help them and make sure they got extra guidance and that sort of thing. But if you tell a child that you are likely to fail, we think that you're not as good as things, or we think you need extra help, that can be a self-fulfilling prophecy, right? People can start to believe that and internalize that. So that's another example that, I don't know. So there's just a handful. That's just off the top of my head. So there's so many examples. So we as practitioners of machine learning really have a duty to look at the data that you're using and examine, how was this data collected and what biases might, exist in that data when you're building models to use it.
So I guess that is the job of a good data scientist,
yes.
to really work with that. I guess that's
yes.
much of your work you're doing.
Yeah, I disagree with most of those.
Okay.
Which is that, one, I don't think that any of this is unique to AI. So collecting data and having sampling bias, that's not an AI-specific issue. A very nice example, you were talking about admissions in schools and that kind of stuff. There's something called Simpson's paradox, which has to do with confounding variables. Mm-hmm. You have samples that are of different sizes and that kind of thing. And it would look like, if you compare, for example, how women are accepted into universities, that they are at a disadvantage because they are accepted at a much lower rate. But the confounding variable here is which departments do they apply to. So women tend to apply to departments that are much harder to get into, and the number of women applying compared to the number of men applying are different as well. So if you break out that statistic and have the confounding variable as an input parameter, meaning the department that they apply to, it turned out that the university is twice as likely to approve women as men if you apply to the university. A deep learning model would never be tricked by that if you have all the data. It's only humans that get tricked by that kind of stuff. We're likely to make lots of mistakes when we try to interpret data. For example, if we include ethnicity and which person should be arrested or not, that is something that we give meaning to in that confounding variable. That doesn't mean that the model is wrong. I mean, otherwise it would have lower accuracy, because it does have a higher accuracy. That just means that if you want to interpret the model...
No, because it was trained using data that was collected by humans. And so if I, as a police officer, had a bias against a certain, and I arrested
Sure.
them more frequently,
Sure.
even though they may have smoked marijuana, same as a white person, then that is a real bias.
But
and
what's
then that's
the
going
optimization function?
The problem is these things are going to get perpetuated, and as you say, I am in agreement in the point that a lot of people just don't understand how they're used. And so people, will see these things and think that machine learning is magic, and okay, this is predicting this, and it's based on this historical data, so it might be right. So my point is just that you really need to think about what's going into that historical data, because as you say, it's just math, right?
I think this issue of confounding variables is not something that AI suffers from. And a good example is a company that we helped that built an AI to help with recruitment.
Okay.
And based on their previous data, women were not hired as often because they weren't as well represented in that company in specific. And so the model learned that. So if there was a woman applicant, it would say, this person's probably not going to get hired. But there were many other variables that were included there, how good they're at programming and other things. And the issue is, if including gender as a variable improves the accuracy of the model when you validate it over the validation set, that doesn't mean that being a woman actually affects whether you get the job or not. It might. But that doesn't mean that that's a confounding variable. So it means maybe there are other factors, how well they present themselves, and those are the ones, if you want to interpret the model, you need to include them in order to understand why are we making this decision. But the model is not doing anything wrong. It's accurate.
Right. If there are other factors, though, judging on things like those factors is, I think, a better use. When you think about examples like figuring out who to give insurance to and stuff, if there are decisions where people are making decisions based on things like gender and ethnicity, like that's just wrong. That's just wrong.
So that's a good example, giving a loan to somebody. Let's say you have data about where they live, and a person lives in a bad part of the city, and that's correlated with whether they'll be able to pay back the loan or not. If that improves the accuracy of the model, that just means that you won't be able to interpret the model well. It doesn't mean that the model is not good, or that the model is being prejudiced against those people. That's not an issue with AI. That's an issue, that's a completely separate societal. How do we interpret what society has given disadvantages to the people that live in this part of the town and that kind of stuff? Yeah. So it's not an AI problem.
But it puts some responsibility on the data scientist to,
if the
to
data
really
scientist,
understand.
So if a data scientist goes back and says, I know what the problem is, it's this, and they point, that I absolutely agree. Then you've misinterpreted it. Then you're a silly statistician. Okay.
We are soon running out of time. This is a really interesting discussion. I feel we could go on for a while on this subject, but
we'll finish over beers later.
I will actually open up for questions from the audience. So, for those of you who are maybe have started looking at machine learning or AI or thinking about how to start looking at it, now is the chance to ask the expert. Or thinking around the future for connected devices for consumers, for example. Yes, a question. Actually, I'm going to give you a mic because since this is being recorded, we want to actually get the question on tape.
Yes. Was the last subject, I guess. Now, this technology is being easier to use and therefore easier to misuse, as you talked about now. How should we deal with that?
Yeah. So the question is, the data, this technology is easier to use, therefore it's easier to misuse. So there's a couple different things to unpack there. The first is that there are responsibilities, I think, on the company. So you guys may have heard democratizing AI, because I think Microsoft is chanting it, and Google is chanting it, and IBM is chanting it. So this idea of providing pre-built models to people for them to leverage, so you don't have to have a machine learning background. You can just call a model and get data back. And so for those types of services, like the Microsoft Cognitive Services or IBM Watson or some of these other things, in those scenarios, I think those large companies have a responsibility to make sure that they're training with sufficient data. They should make sure that they're training across ethnicities, across genders, across ages, with a diverse group of people to be able, for example, to recognize faces well and that sort of thing. So there's a certain responsibility on the companies that are providing those models to make sure that they are actively thinking about these types of things and doing the right thing there. And then secondly, the idea that, okay, now machine learning is getting easier. We're trying to democratize it and make it so that more people without a machine learning background can use it. As you build your own models, that's part of the reason for things like this, I think, is just to raise the awareness and have the discussions and talk about it so that people are aware that all supervised machine learning does is use historical data to make future predictions. So any kind of bias or anything that was off about that historical data will get perpetuated in a model. It's not magic, it's just math. So having, making sure you fully understand the data and kind of what you're doing will help. And I think there's some easy things like to help people like learn and as they kind of dip their toe in it. If you're trying to predict sales, for example, and you were able to use August sales to predict September sales, okay, and maybe September's predicted October's okay, but then like the holidays hit and November's sales didn't predict December's very well because it was the holidays and a bunch of people bought a bunch of things. And so you learn, oh, I actually need to use December of last year rather than the previous month in that situation. So just kind of having this awareness and thinking about it and understanding as you build the models can really help, and then continuing to have the discussions.
With great power comes great responsibility.
Young Spider-Man.
Any more questions? Yeah. No, sir.
So with tools that augment our own capabilities, there tends to be one of two effects. it makes us achieve the task better, but sometimes it makes people less capable themselves. They become dependent on those tools. Is there a risk, and the problem is the tools don't always get things right. Is there a risk that we're going to become dependent on tools helping us to do everything and us not know when the tools are doing it wrong?
I want to answer that one.
Yeah, Rebecca.
Yeah. No, but for real, yeah, there is a risk that we are changing our behaviors and putting ourselves at greater risk due to our tools. So what we are calling it is a safety device paradox. And we can especially talk about our mobile phones, smartphones. Because what we are seeing is that a lot of people are using safety apps, alarms, and different things on their smartphone. But when we're talking to them, we also see that they say that they are less concerned about risks because they have their smartphone with them. So they are also more likely to put themselves in situations where they wouldn't have been if they didn't have the phone with them. And I think one of the best examples of this is, have any of you been hiking in the Swedish mountains? It's like 2, 3 people. Okay, the Swedish mountains, this part of it is still wilderness. And I was up there a couple of years ago, and I was staying in this hut, a community hut. And I was woken up in the middle of the night, and these huts don't have any electricity, no water, no nothing. And I was woken up by a high-pitched alarm, and there is nothing that should be able to make that sound in these huts. And I answered the phone, or I found the phone that was making the noise, and it was the police. And they were looking for a young guy from Holland who was hiking in the mountain, and he was lost. And a couple of days later, I learned that the police had found him up in the mountains. He was up on the mountainside, and he couldn't get back down because he has ventured out in the wilderness without proper education, proper knowledge, or with the right tools with him, because he had a smartphone. And I was starting talking, so one of the benefits of being at Ericsson, I can get to travel the world, and I've learned that this is the same in Australia in the outbacks, and it's the same in Canada, in the big wilderness and the woods. People do like, well, I have a smartphone, I can go everywhere. So what we're seeing as wearable devices, for instance, are getting connected, and one of the paths that the wearables are going is into security devices. You can have rings and watches that can help you with security. People are tending to lean to those as well. And if we are not starting to think about how these different tools are supporting us, it will change our behavior and maybe make us less critical to the situation. And there is also a risk with AI. We have already AI today, research being, to prevent death by selfie, death by selfie. I take a photo over a cliff and I'm like, whoa, fall down. And now they're researching that you can have an AI that can tell you, you know what, this is not a good place to take a selfie on. What happens if that selfies, for some reason, don't alert me, and I'm very used to having those alerts? Will I stop, doing critical thinking myself, or will I just go like, well, the AI haven't said anything. This must be a safe location. So we need to think about how AI are going to give us advice in the future. And it's not only about personal safety, it's also about, where to invest money, what kind of education should I take, or what political party should I vote for. Mm-hmm. We need to know how this affects us as humans. Sorry, this was a very long answer.
Yeah. It's a very good question.
It's worth mentioning that we don't know a lot of basic things already, and we rely on each other. There's a great book by Bruce Schneier, one of the godfathers of cryptography, called Liars and Outliers, that talks about how we need to trust each other in society because we don't know enough on our own to survive. Most of us don't know the chemical composition of antibiotics. Most of us don't even know how to calculate the compound interest on our house loan. And those are pretty basic things. But it's okay, because I trust, which you shouldn't, the bank person to calculate it correctly, because they don't, and so on. And I trust that the doctor has done the correct work with the antibiotics and that kind of thing. So maybe we'll get to a point where we trust AI in the same way.
Yeah, I think it's not specific to AI though too. It's tools in general. have that effect. With GPS, man, I don't ever know where I'm going anymore. Like if it's north, south, east, I just follow the GPS and I get
straight
there.
into the water.
Yeah, I mean, seriously, I probably would follow it into the water. So I mean, and that's not even AI, that's just a pathfinding tool. And even just like calculators, like remember when I don't know the point when you switch over in high school math, when you actually had to do things, and then starting in one of your college classes or something, you could use calculators for everything. Like how fast did you forget how to do math in your head? Like some of those basic things. And I mean, tools, there is an inherent risk to tools that you lose some of how to do those skills yourself. But the benefit, it's again, cost-benefit analysis, and I think most of the time you're okay, but it's a huge thing to think about in terms of how AI and the safety thing and these things are really important things to think about.
So it's just about balancing, the AI comes with so many great benefits that can help us to support us, but at the same time, we just need to be aware about these pitfalls because then we can work around them. So it's not about saying, AI is going to, make us all stupid. It's more like, okay, so how can we work with this? How can we solve it? Be aware of the pitfalls, I think.
Excellent. We are running overtime, so I would like to thank our great panel. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you. So